So what are we looking at here?
So we're looking at, here's the robot arm, our chessboard, and our camera.
Okay,
The three
overhead
main
camera.
hardware things that are here.
Okay.
Basically what's going to happen is the camera is going to be used to identify the human's moves
Okay.
and update the state of the board, and then the rest is all sort of in the computer, the chess algorithm, and so it will determine its next move, and then it will tell the robot arm what move that is. So
Okay.
that move will be made by the robot, then we'll switch back to the camera to re-identify the human move, and that just repeats all the way through.
Okay. And we've got a 5 degree of freedom arm with a gripper.
Right.
Okay.
Right.
And that's all
It's all full chessboard which is being captured and
full chessboard,
full chess.
normal
game.
chess
Normal
pieces. You're tracking the game state internally in the software. And you've got a servo controller with a serial port over to this VxWorks target. Camera, NTSC standard def camera, going to this frame grabber sitting in the VxWorks target as well, and the other card in there is the network card. Okay, that sounds good. Let's see it run.
So I'm switching on the robotic arm.
Okay,
So it's
just
aligning.
powering it,
Yeah, powering it on.
and that goes to its initial state.
So first we'll spawn tasks, and then we're going to
Initialize the game.
init game. So this just sort of initializes the chessboard state and the robotic arm and
First
everything.
move it makes.
So now the robot starts first, and it will make its first move.
Okay,
And here you can see the game state updated on this screen. So you can see he's moved his pawn 2 spaces there,
okay,
And then the same thing is
and then you can look at the board and see that pawn was moved
okay.
those same spaces.
Yep. Okay, so the robot took the first move, and now someone gets to play the
Right.
robot.
So we're gonna start the camera.
and we should not block the view of the camera so that it detects a false move.
Okay.
Okay, so the camera started. So
So we can see the difference frames here, like they are coming online.
Okay.
So you are seeing the move. This is what image processing is seeing,
Okay.
and your difference frame is now 0. So that is the dark one.
Okay.
So you have to make your move, and it is asynchronous event.
Right. So it hasn't
So-
detected any
Anything
move
changed.
made by a human yet. Yeah.
Right.
But you did have to like switch it back into an observing mode. Is that right? You manually switch it in and out of.
Yeah.
I'm gonna take my move now, kind of thing. Okay.
So I'm making a move. Human move.
And it was watching for it, and
Yeah,
it
it
saw a
is.
difference.
So right now it's calculating the differences.
Okay.
And it
And
is
so
New game state,
now this is the new game state with the
this one is
robots.
and the robot's making
So you
its
can
counter
see
move.
the
Yeah.
human's move is updated and
Yep.
the new robot.
the same move
Okay.
is being updated.
Yeah. So the robot, as soon as it sees a new game state, immediately calls into the game engine and makes its decision, and then moves right away.
And then
And then it waits for you to say, basically. Oh, so at this point, can you just make your next move, or
yeah,
do you?
you can.
Oh, you
So
can.
now it says robot moves successfully.
So
You have to
that
wait for
camera
the step.
initialization
That
was
just
a
the first
one-time
time,
thing.
yeah.
Okay,
That was just the
got
first
it.
time. So
Okay.
now it says robot moves successfully, so we can go ahead and
Okay.
make our move.
So I have moved a
The knight.
move.
Yep.
So it detects that see knight has moved from that place.
And you can
to-
see he's going to take our pawn with his pawn.
Okay. Okay. Yeah. So he doesn't actually remove the piece that he takes.
we have that algorithm, but
Yeah. Okay.
not
All right. Yeah. Not fully implemented, but could be.
yeah. So we
Right.
can again make a move.
Okay.
So we are going to take his
His
capture
pawn.
So that frame it is detecting.
We've got a new game state,
So we have.
and he'll make his move as soon as he gets the new game state. So how does he decide on his move? Is it kind of a classic minimax type function, or how smart is
It
is the
You can
robot?
you can see here, these are the possible moves it may make.
Okay.
And these are the score that it gives these moves.
Actually, it is.
So it does kind of a depth and breadth
Yeah, it is
first search kind of a tree of possible moves.
Yeah,
Exactly.
in the
And then
standard chess algorithm, the depth is from 1 to 10.
Yeah.
And it plays around 6th level.
Yeah, so you've got an evaluation function, and you've got basically a tree search algorithm for all possible moves. You apply the evaluation function, and you take what, in theory, is the optimal move.
Correct. So,
Yeah, okay.
so if you want to make the next.
But is he also taking into account the moves that the opponent could make in response? He is.
right.
And you're going down to 6 levels, you said?
Yeah, 6.
Okay.
Now we can see the 4 levels there. So first
Okay.
level, second level, third level, fourth level, whichever is best among those levels.
Okay.
It is making that move. So
Okay.
D8, D7 is the 12th
Board.
board state. That is what
Yeah.
is taken.
Yeah. Okay. He's always maintaining an internal board state and looking at the board state if any of those moves are made, and then evaluating his advantage in that case.
You can take the knight with the knight.
Right.
Capture.
Okay. So the humans are doing pretty well so far.
He's quite good though.
Yeah.
Is this it? He picks up later? Okay.
That's what he has done. Now he's picking up our.
Capturing with the bishop there.
Okay.
So it plays the full game until the
King is.
king is.
Can it
checkmated.
can it detect that?
Yeah, you can
Yeah,
see the
it,
check
it
is
knows when
checkmate.
it's been checked.
Okay.
It knows when it's checkmated us. So far, we don't know what happens when we checkmate it because it hasn't happened.
Yeah.
Right. Okay. And you said the only moves that it doesn't support that are valid chess moves are en passant and the castling.
And castling.
And
right.
percent is one thing because we can do that. We have supported that, but
Yeah.
except castling. Castling has 4 state change.
Yeah.
Right.
N% has only 2 state change. So
Yeah.
still we can do that.
I mean, given more time, you could probably do that, right? Because it would just require the robot arm to make multiple moves.
Right. Right.
And yeah, so
It would be easy to make the robot arm do it. It would be more difficult to recognize it with our vision algorithm
okay.
if we did a castling move.
Right. Right, understood.
Because there would
Yeah.
be four
Multiple
four
changes
instead
occurring.
of two.
Yeah. So the real-time aspect is the 30 frames per second observation of the board. Is that right? And the image processing getting done at that rate. And then
Processing, yeah, we are doing 10 frames from that.
right. Right.
Every
Okay.
third frame.
Yeah. Every third frame. So you're operating at 10 hertz.
Yeah.
So you can detect a change in the board state at a 10 hertz rate. You command the arm. It has to essentially recognize the. Does it actually recognize the piece, or does it recognize the location on the board?
Or it just recognizes the
Basically just
Location. Yeah.
It knows what piece
It's
was there
seeing the grid.
previously.
Yeah.
Right.
It's so rather than doing image recognition of the piece, it's doing image recognition of the
yeah,
board and maintaining a
because-
constant full board state history,
Yeah, because we
essentially.
are using an artificial intelligence test engine there. So
Yeah, that makes sense. Yeah.
what we have.
It seriously simplifies the vision algorithm.
Oh, sure. Yep, yep. Well, that's a good plan. I mean, there's nothing wrong with that. So that's information you have. All right. Well,
can
anything
make a
else to add for the video or? Oh, make a move. Well, let's see. Okay. So, yeah. Okay.
So with
All right. I'm black, right?
Yeah.
Okay. Oh, jeez. Probably gonna think about this too much. I think I'll get my queen into the game. But carefully. All right, this is probably dangerous. See how the robot responds.
He's gonna bring out a knight to force you to move your queen next time. It looks like.
Yeah. Keep the queen moving.
Yeah.
Yep.
that's what it
Yeah.
happens. So.
Excellent. All right. Well, that's probably pretty good. So we'll continue the rest of the game off camera.